Hi, Aditya.
Hi.
Thank you so much for doing this interview.
Absolutely.
Before we start, may I ask you to briefly introduce yourself in terms of your background, education, research interest, and work?
Yeah, I'm a quantum theorist and I work at the intersection of quantum information theory and gravity.
Mm-hmm.
And my background is I did a PhD at the University of Oxford, and before this, I was in Hong Kong where I did cosmology at the Hong Kong University of Science and Technology. I've always been interested in physics and going beyond like what we can see and observe, and that's why cosmology fascinates me.
Mm-hmm. So you got your Bachelor's of Science degree in Physics and Mathematics. How come you have decided to pursue a degree in both physics and mathematics?
I think at the time I was very interested in trying to understand the mathematical foundations of some famous physical theories like general relativity, string theory, and quantum field theory. But as I kept doing more and more physics, my interest gravitated towards what we can observe and what we could compute, and I was less interested in the mathematical foundations of those theories.
Right. So what was your main research area here at Oxford during your PhD?
I worked on finding signatures of quantum gravity, particularly in the early universe. So I proposed an experiment in the laboratory where you could potentially detect signatures of quantum gravity in a BEC. And then I went on to explore what the consequences of that would be when applied to cosmology.
Cool. So how would you explain quantum gravity to a complete layman?
It's essentially the intersection of two fields. Like we have Einstein's theory that tells us matter curves space and space curves matter. But the matter that we see around us is actually quantum. So why shouldn't the thing it causes also be quantum? So quantum gravity is an attempt to describe gravity in quantum mechanical terms.
I see. So you're also interested in cosmology. So what do you find fascinating about cosmology?
The fact that it is so much bigger than us, and the most interesting thing that we can see in the universe is the cosmic microwave background. It is one measurement that happened at one period of time, and it can tell so much about the evolution history of the universe. And that's the fascinating thing about cosmology.
Right. So what are cosmic strings?
Cosmic strings are topological defects. If you imagine you have a kettle of water that you're boiling, there are these little bubbles that form in your kettle surrounded by liquid. So you can think of a cosmic string as one of these bubbles in a kettle of water, which is the universe.
So you worked as a research student at CERN. Can you talk about the projects you worked on there, and what was that experience like for you?
It was a very good experience. Unfortunately, when I was there, the Atlas Collider was under maintenance, so I couldn't see it in action.
Right.
But it was a very interesting experience in the sense that you got to attend all these cutting-edge lectures. And I worked at morphing methods, which was to look for beyond the standard model signatures. So physicists believe that there are particles beyond what we can see and observe that interact with us gravitationally. And my research was to look for signatures of those particles.
I see. So why is the Higgs boson important, and why it's also called God particle?
For a long time, we didn't understand what gave the particles that we see around us mass. So why is an electron heavy? We didn't have an answer to this question.
Yeah.
And that answer was given to us by the Higgs boson. It is probably the most important fundamental particle after the graviton, if it exists. I think there is a lot more to be said about the Higgs boson. There are a few computational mysteries that still remain. But as far as the particle itself, I think it exists, and we found it about 8 years ago.
So is it really God's particle?
Yeah, in my opinion, yes. Yeah.
Okay. So you co-founded a company called Alice?
Yeah.
Yeah. What are the company's main objectives and plans for the future?
We essentially do causality, which is causal inference, which is a novel form of artificial intelligence that aims to apply cause and effect relationships to AI models. And the long-term goal would be to find a worthwhile problem to apply this to.
Excellent. So are you collaborating with some of the startups here in Oxford?
We're collaborating with the broader Oxford ecosystem. So we're working with the Nuffield Department of Orthopedics and Musculoskeletal Diseases, and we're working with Oxford University Innovation as well. And do you have any employees so far? Yes, we have a couple of employees.
Cool. So what do you work on as a postdoctoral researcher here at Oxford?
I work on the same thing I did in my PhD, which is signatures of quantum gravity, except now I'm also thinking about time and the role of time in the universe.
Cool. Will quantum computers break RSA encryption?
Quite possibly, yeah. We're getting to a point where we can factor large numbers, and quantum computing promises that we will be able to do that.
So what can we expect from a useful quantum computer? So what are the possible applications?
There are a lot of applications in the sense that people are looking at quantum computers for drug discovery. They're looking at synthesizing novel molecules or simulate complex atomic interactions like density functional theory. And there's also the other applications to finance where you can use quadratic unconstrained binary optimization to optimize parts of your system or understand financial markets better.
What is your favorite quantum algorithm?
I would say Deutsch algorithm.
Deutsch?
The very first.
I thought you were going to say Shor's algorithm.
It's a close second, but the Deutsch algorithm is very elegant and a very good illustration of why quantum computing is what it is.
I see. Have you met David Deutsch here in Oxford?
Yes, I've had the pleasure of meeting David.
And what is he like as a person?
He's a very interesting person with a lot of interesting things to say. And everything that comes out of his mouth is pure insight, which I think it's refreshing always.
And basically, he is a colleague of your supervisor?
Yeah, David and Vlatko do share a lot of conversations, and he works extensively with Chiara and my friend Sam.
Is there some person from the quantum science which you would like to meet, but you haven't met him already?
I would like to meet John Preskill.
Okay.
There's a lot of work that he does on simulating field theories on quantum computers that I'm interested to learn about and talk about.
Right. Do you have a role model in science?
Without sounding too cheesy about it, I'd say my supervisor is a very good role model. Vlatko has perfected the way of scientific thinking and bridging philosophy with science. But other scientists come to mind, like Einstein as well, the sheer brilliance of just thinking about things like time that nobody thought about.
What do you think about Richard Feynman and his legacy?
He's an amazing person, and I grew up reading most of the Feynman lectures, and that's one of the reasons why I became interested in physics. And Feynman also had a huge influence in shaping research direction in quantum gravity, even though he was not fully comfortable with quantum mechanics at the time.
I see.
So he's a very interesting researcher to follow.
He said something like, "You are crazy if you believe you understand quantum mechanics."
Yes.
So basically, that is 100% true.
Yes, that is very true. To this date,
yeah. Is time travel possible?
Perhaps. There's no law of physics preventing time travel from happening. Some may say the second law of thermodynamics prevents us from going back in time. But quantum theory says everything's unitary, so time travel could become a thing in the future. And if you could predict when it would be possible to travel through time? Maybe 200 years.
200 years, okay, so...
maybe immortality is something we can get before time travel. Yeah, that's my opinion on that.
What do you think about mortality?
Most people think of it as a disease, and I agree with that. Aging seems like a disease, something that you could fix.
Okay, so you believe that. And what do you think about those superhumans, like using AI and robots to increase human perception, human illnesses? So do you believe that one day we will be some kind of a mixture between robots and humans?
I don't know which will come first. If I had to guess, I think therapeutic advances could extend our span of life much faster than us integrating with silicon beings. So yes, while advances in VR and cybernetics are great, I do believe that medicine has gone much further than this area has.
One interesting question. Do you believe we live in a simulation?
So I work at the Foundation for Quantum Theory and Gravity, and one of the theories that often come up in this area of research is ADS-CFT, which gives us a good reason to believe that we're in a simulation, if true.
Yeah.
So it is not, I wouldn't believe or disbelieve the fact that we're in a simulation. If someone came and proved to me tomorrow that we were in a simulation, I wouldn't be too surprised.
And so you believe that we live in a simulation, so who is the simulator?
That's like the anthropic principle. You just keep asking higher and higher till you find something. I don't believe there's any simulator. It could just be the universe originated spontaneously, and the laws of physics are what gave rise to this simulation.
I see. Yeah. So can we perceive the universe as an information processing system or computational device?
Yes, absolutely. The universe processes tons of information every day. The very vacuum you see around us is entangled. And entanglement is viewed as a resource for quantum computation. So it's not unthinkable that the universe is a perfect computer. And there are several models of time, for example, the Page-Buttis picture, that perceive the flow of time in a computational way as well. So yes, the universe can be regarded.
Right. What do you think about Elon Musk and his SpaceX company?
I think it's quite nice to actually take bold steps to try to put people on Mars and reusable rockets. I think that's where the whole allure lay in the beginning. And yeah, my personal opinion is that it's great, and I look forward to see where it's going.
Would you travel to Mars?
If it becomes economically feasible, yes, I can travel to Mars.
Right. Okay. So, do you believe there is intelligent life in the universe?
Yes, I do believe there's intelligent life in the universe. In fact, there's the Drake equation that can actually give you a nice probability on what the probability of intelligent life would be in our universe.
So when you think about intelligent life in the universe, do you think about like human-like creatures or some particles, or what exactly?
I think the nature of life doesn't matter more than the ability to process and adapt. So depending on what conditions this so-called life formed in, if it were able to respond and adapt to those conditions while developing the ability to process information in the way we do, I would call that intelligence. That need not necessarily be carbon-based life form.
Right. So, are you a believer in the theory that extraterrestrials will come visit us someday?
That's unlikely, given the universe is such a vast space, and if the human beings were to send a signal to reach the nearest galaxy, it would take about 4.5 billion years to get there. So if intelligent life did exist on another galaxy and they tried to communicate with us, if they're living life in the same way we are, they probably wipe themselves out.
Right. What is your favorite planet in the solar system besides Earth?
Mercury, because it gave us the evidence we needed to verify general relativity.
Right. Okay, so what will the next decade bring for quantum science, in your own words?
I think the next decade will see an improvement in areas like quantum cryptography and quantum generated random numbers. There's this Oxford startup called Quantum Dice that's doing pretty interesting things in quantum generated random numbers. So I think the near-term goal is not to build a quantum computer that people can use, but rather use quantum technology to facilitate other advances in cybersecurity or the quantum internet.
I see. So what do you think about concepts of time and infinity? Do you often think about those concepts?
Some would say time is infinite, but others would say time is finite because the universe is going to expand into thermal death. So depending on which version you believe, time can be infinite or not. And I think that's a fascinating thing, that the human mind is able to think of something that will far outlive its lifespan.
Have you ever worked in the field of AI?
Yes, I've worked in the field of AI. When I was in CERN, I was building a few machine learning models for we understand models.
Have you used supervised learning, reinforcement learning, unsupervised learning?
Not for this particular thing. We just used classification algorithms. But yeah, I have worked with supervised and unsupervised learning.
Yeah. So what do you think about AI in general, and how do you compare it with quantum technology in the future?
I think AI is a kind of function fitting, where you have a problem and you're trying to approximate the best function that could achieve your vision for that problem. Whereas quantum computing is trying to fit multiple different functions at the same time to achieve the thing that AI is doing. So that's the exponential speed up that differentiates quantum computing from classical computing.
Right.
There's not a perfect one-to-one correspondence that exists between the things I'm saying. But yeah, essentially, I think AI, quantum computing, will enable much faster AI in the future.
Right. So what are your plans for the future? Are you looking to stay in academia, or are you looking to work in industry?
I would like to stay in academia very much. I like the research that I'm pursuing, and being in academia has also allowed me to interact with the industry in many ways. So it's not something that I'm missing out on.
Right. So what can you say about the University of Oxford as an educational and research institution?
I think the University of Oxford is a great place to work. The Department of Physics especially facilitates the culture of open exchange and interaction. The university is obviously slow in many ways, but it tries to adapt and catch up to the latest trends and heavily encourages entrepreneurship. In that sense, I think it's a great place to be.
Is there anything else you would like to add? Maybe some message for our listeners and viewers?
I think the ultimate message is to stay curious and to not be afraid to try anything at all, because one day it may lead you to solve the mysteries of the universe.
Well done. Aditya, thank you very much for this conversation.
Thank you very much for having me.
Yeah, it was really wonderful talking to you, and I wish you all the best in your career.
Thank you. Thank you so much.
Thanks so much.